If you look at 22b, 37 to 53, it says each of the functions is 1-to-1. How nice. Find its inverse and check your answer. State the domain and range of both f and f inverse. So we know what an inverse does. Right? If we had a domain, and it has to look like this because it has to be 1-to-1. So f takes the domain and turns it into the range, and f inverse goes backwards. Okay? Well, if I had the function f of x equals x plus 1, so that turns the number 1 into the number 2, and the number 2 into 3, and 7 into 8, and negative 5 into negative 4. So the inverse does the exact opposite. 2 gets turned into 1, 3 gets turned into 2, 8 gets turned into 7, and negative 4 gets turned into negative 5. How long would it take me to list all of the inverses? Forever. Now, the original function turns x's into y's, okay? And then the other function just switches those. This list becomes my new y list. And my original y list becomes my new x list. So there is a very simple way to switch every single point using the equation. And here's how you do it. F of x is also known as y. So y equals x plus 1. I want to turn every single x value into y values and every single y value into an x value. So all I do is I change this into x equals y plus 1. Now I have switched them, but there's a problem here. How do you graph x equals y plus 1? Well, you got to solve for y. So I will subtract 1, and I get y is equal to x minus 1. Okay? So my function is x plus 1, and my inverse function is x minus 1. Okay? So that was pretty easy. Let's do, so some of you are working ahead. Okay. Well, let's do another simple one. So y, well, and again, it's actually going to be f of x equals 2x minus 3 over 4. Okay? So y is equal to 2x minus 3 over 4. To perform the inverse, I turn every x into a y and every y into an x. So x equals 2y minus 3 over 4. Now I just solve for y. And you guys know how to do this. What do I move first? The 4, I times by 4. And then I add the 3. Then I divide by 2. So f inverse of x is 4x plus 3 over 2. Does that make sense? So I just switch the x's and y's and then solve for y. Okay. Do you want me to do one with the negative x? Is that where you're getting confused? Okay, so if I had y equals 3 minus 2x, then I would get x equals 3 minus 2y. How do you solve that? Subtract the 3 and divide by negative 2. And I'm done. Oh, you're here. We didn't say anything mean about you. That's a height problem. It's not a hair problem. Okay, but what about this? So wherever you are, stop. I know you guys are working hard. You want to see this. If I have f of x is equal to, let's do the square root of x plus 2 minus 3. What is the inverse? Well, I get y equals the square root of x plus 2 minus 3, and I can invert x is equal to the square root of y plus 2 minus 3. And actually, I'm going to change. That's not what I wanted. Let's change that to a minus 2. Okay. Now I have to solve for y. No. What do I do first? Add the 3. So I get x plus 3 is equal to the square root of y minus 2. Now what? Square it. And I get x plus 3 squared is equal to y minus 2. So I add 2. And I get this. Now, is x plus 3 squared plus 2 1-to-1? No, because it's a parabola. So something is going on here. I took an equation that is totally invertible, and when I inverted it, I ended up with an equation that is not invertible. Why is that? Well, this one's not 1-to-1, but the original function was. So it should be able to go back and forth. And the problem is the domain. So let's go back up to the original. What is the domain of f of x? Are there any numbers I'm not allowed to plug in? Well, this has to be greater than or equal to 0. So x, let's get rid of this, x minus 2 has to be bigger than or equal to 0, so x must be greater than or equal to 2. Just out of curiosity, what does the square root graph look like? So if I draw this, square root graph looks like that. Where is this particular square root graph? Well, if I do transformations, the negative 2 moves it right 2, and the negative 3 moves it down 3. So right 1, 2, down 1, 2, 3. So 1, 2, 1, 2, 3. Okay. What is the domain of this? 2 to infinity, right here. Okay. So the domain is 2 to infinity, including 2. What's the range? Negative 3 to infinity. Is everybody okay with that? So when I go down here, what is the domain of this? Are there any numbers I'm not allowed to plug into x plus 3 squared plus 2? No, but my original equation did have restrictions. And those restrictions are going to translate into restrictions on the other one. But let's do the inverse. So here's my line. This point right here is 2 comma negative 3. When I invert it, where does it land? 2, negative 3, the x and y flip. So negative 1, 2, 3, and positive 2. Okay. And it's going to look like this. Right? That's going to fold straight over and look like that. What is the domain of this piece? Negative 3 to infinity. And what's the range of that piece? 2 to infinity. And what do you notice? They just switched. Does that make any sense? Yes, because the inverse just switched my x's and my y's. Okay, so what is the domain of this? Well, it's the range of the original problem. Does everybody see that? And this will be on the final, I can guarantee it. Okay? They will tell you this is f of x. Did I confuse you, Bell? Where'd you get stuck? Oh, okay. Well, hold on a second. I'll show you that in just 1 second. So here is f of x. And the question on the final will say, what is the domain of f inverse? Do you need to do all of this work to find the domain of f inverse? No, the domain of f inverse is always equal to the range of f. So domain is really easy to find. Domain, you just look for square rooting negatives and dividing by 0. Okay, how do you find a range? You have to graph it. So I graph it, and we're talking about this piece here. The range is made up of y values. Are there any of these y values that miss the graph? And the answer is all of these miss the graph, and they don't start hitting until right there at -3, and they keep hitting forever, which is why the range is -3 to infinity. So range, and once you get really good at graphing, you can do the range in your head, but I don't know that you guys are there yet. So you might just have to graph it to find the range. Okay, but notice, the domain of the original is equal to the range of the inverse, and the range of the original is equal to the domain of the inverse. So down here, even though it looks like this is defined everywhere, we have to include the original domain and range restrictions on this function. Okay? Otherwise, we used an invertible function to create a non-invertible function, and that's just impossible. You can't do that. Okay? All right, so let's do a couple from the assignment. 38, or well, from the set. 2x plus 3. So this is my f function. My inverse function can be found by doing x equals 2y plus 3. And I subtract 3 and divide by 2. Y equals x minus 3 over 2. What is the domain of the original? Does the original have any domain restrictions? No. So it's all real numbers. What is the range of the original? Well, what kind of graph are we looking at? 2x plus 3 is a linear with a positive slope. Are there any y values that a line misses? Nope, so it's all real numbers. So if the domain of the original is all real numbers and the range of the original is all real numbers, what about the inverse? Same thing. You turn every x into a y and every y into an x. If there are two x's, they both become y's. But that's not going to happen today. All right. So let's look at 40. 40 is x to the third minus 1. So this is my f. F inverse is going to be x equals y to the third minus 1. How do I solve that? Add 1, so I get x plus 1, third root. Do I need a plus or minus? No, because not because it's not negative. It's not a square root or a 4 or a 6 or an 8. It's odd. Okay? So, does this have any domain restrictions? No. So the domain of the original is all real numbers, which means the range of the inverse is all real numbers. What does an x to the third graph look like? Looks like this. Right there. Does it have any range restrictions? Nope. It's all real numbers, so the domain of, so down here, domain is also all real numbers. All right. 42. 42 is a good one. Y equals the square root of 3 minus x. Does this have any domain restrictions? So we know that 3 minus x has to be greater than or equal to 0. So I'm going to subtract 3. Negative x is greater than negative 3. Make sure you're watching this. Now what? Divide by negative 1, and I get x is less than or equal to 3. Because whenever you divide or multiply by negative, you have to flip the inequality. So my domain is negative infinity to 3. That's for my original graph. So for the inverse, the domain is going, or sorry, the range is going to be negative infinity to 3. Okay? Well, where is this square root graph on, well, where is the graph, I guess is what I'm saying. What does it look like? It's going to go left instead of right because of that negative, and it hits at 3. So it looks like this. Does everybody understand why? Well, look at the domain. The domain is negative infinity to 3. Okay. Does the original equation have any range restrictions? It has to be 0 or bigger. Do you get that, Bell? So we draw a line through the y-axis, and we move that line up and down, and we have to decide which y's hit the graph and which ones don't. So none of these down here hit the graph. The first time it hits is at y equals 0, and then it continues to hit for every single y value all the way to positive infinity. So the range is 0 to infinity, like that. Which means the domain of the inverse is 0 to infinity. Does that make sense? Okay. Now, what is the inverse? Well, x equals the square root of 3 minus y. How do I solve for that? Square both sides, and I get x squared minus 3 equals negative y. And then I'm just going to go through and change every sign. Right, times by negative 1. So negative, positive, positive. And y is equal to negative x squared plus 3. But wait a minute. Negative x squared plus 3 is not 1-to-1. How do you justify that? When you look on this domain, it is 1-to-1 because the other half gets thrown away. So negative x squared plus 3, that graph actually looks like this. 1, 2, 3. But we're only allowed to look at the right side. So this piece gets thrown away. And this piece stays. And you can see Those are inverses. The red one and the blue one are inverses. Okay. All right. Ooh. Let's see. Um, let's do, let me show you how to do 50. So y equals 7 over x plus 2. First off, any domain restrictions? X cannot equal negative 2. And then if you graph it, you need to figure out what y cannot equal. And it turns out y cannot equal 0. Okay, you'll just see that from the graph. And so here, x is equal to 7 over y plus 2. How do we solve for y in this case? Not 2. Put the 7 over. So, oh, going back to your trig, swapping this. That actually does work. I'm not sure that's. One thing you could do is cross multiply, but that's kind of messy. So I'm going to do this. I'm going to times this side by y plus 2 and cancel that, and times this side by y plus 2. So I get xy plus 2x equals 7. Now what? Subtract 2x and divide by x. And I get y equals 7 minus 2x over x. Okay. Look at 52. 2x plus 5 over 7 plus x. Now this is kind of tricky, but we're going to do the same thing. X equals 2y plus 5 over 7 plus y. And there's one little trick here that makes it a little bit harder. I'm going to multiply by 7 plus y. Those cancel. 7 plus y, 7 plus y. So I get 7x plus yx is equal to 2y plus 5. Everybody understand that? Now, there's a problem here. Does anybody see it? I have a yx and a 2y. So I don't think you've ever had to solve a problem like this before, but I'm going to put all the y's on the left and everything else on the right. So yx, and I'm going to subtract 2y, is equal to 5 minus 7x. Everybody see that? Now, how can I get the y into the two different y's into a single y? Well, if I divide by x, I actually have to divide everything by x. And that doesn't get us anywhere. So that doesn't work. And the same thing, I run into the same problem when I try to divide by negative 2. So here's what you do. You factor out a y. And I get y times x minus 2 is equal to 5 minus 7x. Now how do I get the y by itself? Divide by x minus 2. So y is equal to 5 minus 7x and x minus 2. Now if we go back up to the original, in the original, x is not allowed to be negative 7. So the domain of the original is negative infinity to negative 7, union with negative 7 to infinity. That becomes the range of the inverse. Okay. Oh, really? This is kind of tough. Oh no, it's not too bad. So if you graph this, actually, let me just do it. Let me graph the original. And make sure you use parentheses. 2x plus 5. Oh, oops. 2x plus 5 and, wow, divided by 7 plus x. So I know that x cannot equal negative 7. But do you see a y value that we don't reach? If you look on the graph, you can see it. No, a y value. It's actually x equals 2. And that's a little bit hard to see, and we'll get to horizontal asymptotes later. We did them last year, but so just graph it and figure out where those are. And I'm not terribly concerned that you get the range right on these problems because we'll be doing stuff later that will help us with the range. All right. Okay, get to work.